Alright, hopefully you had enough time to complete your warm-up. So let's look at this real quick. So what we're going to do, we're going to look at this and say find the probability that a randomly chosen student in this history class received a C or better. So C or better, so C, B, or A. So the probability of a C or better, now let's fix this. That's going to be, alright, 8 plus 12 is 20, plus 7 is 27. So I have 27 successes over how many total students do I have? Well, if we add 27 plus 1 plus 3, there are a total of 31 students in the class. So that is the probability. Like we talked about yesterday, number of success over number of possible. So we have 27 students that get C's or better out of 31 total students in the class. Now B, find the probability that a randomly chosen student in this history class earned less than an A. Okay, so less than an A means anything lower than that, not including an A. So the probability that we have less than an A, that's going to be any grades F, D, C, or B. If you add all those up, that's 24 out of a total of 31 students. All right, so you find the probability that a randomly chosen student in this history class passed the exam. So pass means you got higher than an F. So the probability that we passed, that's going to be, if you add up 1, 8, 12, and 7, that is 28 out of 31 total students. Then the probability of getting a C or D, all right, if we add up the number of C's plus the number of D's, that will give us 9. So 9 out of 31. And the probability of an F or B, we have 3 F's and 12 B's, so that is 15 out of 31. Okay, so hopefully you guys did pretty well on that warm-up. Let's get into the notes for today. Alright, so the Monopoly problems that we're going to talk about are over here. So let's look at that, and we have a Monopoly board as well to kind of help us out with the visual. So Monopoly is one of my favorite games, and I actually use this to kind of figure out my strategy when I play with my family. So let's look at these problems. First one, you're playing Monopoly with your brother and he has 3 houses in Park Place. You are currently on Pacific Avenue and trying to figure out how likely it will be that you land on Park Place on your turn. Okay, so let's look at Park Place. Park Place is right here. I'm sorry, that's Boardwalk. This is Park Place, and Pacific Avenue is right here. So it's 1, 2, 3, 4, 5, 6 spaces away. All right, so the first problem, we're going from Pacific Avenue to Park Place, and that was 6 spaces. So we got to figure out how likely is it for me to roll a 6. So the probability that I roll a 6. Well, I have this chart over here. If we roll 2 dice, these are all the possible outcomes over here. So how many 6s do we have? 1, 2, 3, 4, 5. So when we roll these two dice, or two die, we could get 5 combinations for a 6 out of a total 36 possibilities. So our probability will be 5 out of 36. All right, let's go back and look at number 2. You're on shoreline and are hoping to pass go on your next turn. What is the probability that you will pass go and receive $200? All right, so we got to find out where shoreline is. Let's see. Oh, right here, the Shoreline Railroad. Let's circle this. Okay. So I'm going to get rid of these two. So we're 1, 2, 3, 4, 5. We're 5 away from go, but let's see. The problem here wants us to pass go. So a 5 is not okay. We want to get a 6 or better. Okay, so 1, 2, 3, 4, 5, 6 will put us here. And if we just want to pass go, it could be any number bigger than 6. So let's go back and look at the notes. So we are going from shoreline to pass go. We need 6 or greater, or bigger than 5. We need more than a 5. So it's going to be the probability of rolling greater than 5. So let's look at our dice thing here. So we know there's 36 possible ones all down here. So we can count how many would not work and do 36 minus that. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 10 numbers will not allow us to pass go, which means over here, all of these numbers will work, and there's 26 of them. You can go ahead and count them if you want. There are 26 possibilities to get a number bigger than 6. So it's going to be 26 out of 36. Okay, so then the next problem, unfortunately you landed in jail, and in order to get out you need to roll doubles. What is the probability you will get out on your next turn? Alright, so we're in jail. Now, maybe I should have explained this earlier when we started. If you're not familiar with the game of Monopoly, that's when you start with these pieces over here, and you roll 2 die, right there, and you move that many places. Okay, so if you've never played before, that's basically how you play the game. You roll 2 dice, you move that many spots, and you can buy property, and some other things can happen on the board. One of the things that happens is that if you roll, or if you're in jail and you roll a double, you get to get out of jail for free. Otherwise, you have to pay $50 and leave, and then you can leave. But if you roll a double, you get out for free. So if we look at our dice, how many doubles do we have? We have 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, 6 and 6. So we have 1, 2, 3, 4, 5, 6 possible doubles. Okay, so the probability of doubles, that's 6 out of 36. So we don't really need to reduce that. We can leave it just the way it is. All right, let's look at the poker problem. So on that same page over here, go down here, we have a poker problem. So who is more likely to get a straight? Why and how do you know? What is the probability that the guy on the left will get a straight, and what about the guy on the right? So if you don't know what a straight is, it's when the cards are in numerical order. So here we have ace is low, the lowest card, so ace, 2, 3, 4. So this person needs a 5. Let me use a color that stands out a little bit more. So this person needs a 5. Now this person has 8, 9, 10, and jack. So the next highest card is a queen, but this person could also get a 7 and make a straight the other way, with 7 being the lowest card and 10 being the highest. The person on the left could not do that because ace is the lowest card. So only one card will help the guy on the left. He needs a 5. The guy on the right needs a 7 or a queen. So I also have this nifty handout. Alright, there are a total of 52 cards in the deck, and there are 4 5s. So the probability for the guy on the left is 4 out of however many cards are left. So let's go back and figure out how many cards are left in the deck. Okay, so there are normally 52 cards in a deck, but 1, 2, 3, 4, 5, 6, 7, 8 cards are already out of play. They're already been dealt. So let's write that down so we know why we have the numbers that we have. So the problem is who is more likely, whoops, I don't like that, to get a straight. And remember, 8 cards have been dealt. So we have 52 minus 8, which is 44 cards left. Okay, so the guy on the left, he needed a 5. And there's only 4 5s in the deck, so his probability is 4 out of 5. Oh, sorry, 4 out of 44. Because, use color, he needs a 5. Now the person on the right, probability of the guy on the right, that person could use a 7 or a queen to get a straight. So there's actually 8 possibilities out of 44. So 8 out of 44. He needs a 7 or queen. So the person on the right is more likely to get a straight. Again, when you're actually playing cards, you can use this to your advantage. Blackjack is a pretty basic game that really that you can really use probability to help gain the advantage over other people. So all this was theoretical probability, where we said, hey, what do we think will happen based on what is left in the deck or the numbers on the dice? Experimental probability, it sounds more fancier than it is, but all experimental probability is, it's the probability of an experiment. So we actually are doing something and and figuring out what the probability from that actual event. So let's look at this spinner. We're going to have red, orange, purple, yellow. Well, I'm not going to write in yellow. And green. So what should happen, the theoretical probability, or what should happen, means the probability of green, or any of these, but we're going to use green because it's my favorite color. The probability of green should be 1 out of 5. So what we're going to do is we're going to spin a spinner 5 times. All right, we're going to spin this spinner 5 times, and we're going to see what actually happens. So spin. Okay, we got one green. We got red. So we're going to spin it again. We got purple. Third spin, purple again. Fourth spin is green, so we have one green. And look at, so we got a yellow. So in this case, our experimental probability, which was 1 out of 5 spins, actually was the same as our theoretical. So in this case, it worked out. So experimental probability is what actually happened. And this is kind of like how I was talking about the SAT, and I said that you should guess the same letter down because we said theoretically we should have about an even number of A, B, C, or D answer choices. That would be our theoretical probability. But I also said that it's not going to be exact. So your experimental probability would be slightly different. In this case, they were actually the same. So for last one is we're going to be rolling a die, or a dice, however you want to call it. So remember theoretical probability, what should happen. So my favorite number out of 1 through 6, let's do the number 3. So the probability of rolling a 3 is 1/6. I don't like that. 1/6. So then the experimental probability is going to be what actually happened. And for that, I have another tool. Okay. So if we roll this dice 6 times, we should get 1, 3. So let's roll it. Okay, so we get a 5. We're going to roll this 6 times. We get a 4. Another 4. Oh, there's a 3. A 6. And a 2. Dang. So what actually happened, the probability of a 3 was 1/6. I was really hoping that we would have an experiment where we didn't get the theoretical probability, but that's the beauty of experiments, is that sometimes you get what you should get, if that makes sense. I don't know. But I was hoping that we would see a little bit of variation. But I guess not. So this probability stuff is pretty interesting. we'll talk about it more when I come back tomorrow, and we'll be ready for your quiz on Tuesday of next week. So hopefully this helped. If you have any questions, maybe you could have this go back a little bit in the video, pause it, watch it again, ask your classmates. So I guess I'll see you guys then tomorrow. Bye.